Okay, Unit 1 Assessment Review. Be your first test coming up in 2 days. Solve the equation you have for the variable. That's what solve the equation means. You're trying to find what variable y equals. Just put the answer over there. So you have 4y minus 6 equals 2y plus 8. So this isn't simplified to a point where we can just add and divide, or subtract and divide, or subtract and multiply. You have two different variable terms. They're on opposite sides. You cannot just divide. You need to get that out of your system. When you have two variable terms on opposite sides, you pick one to take out by adding and subtracting. So I'll subtract the 2y, and that would have to go with the 4y. So now we have 2y minus 6 equals 8. Now I have it pretty well simplified, where I can use inverse operations. So what are the operations? Well, we got times and minus, okay? So the minus 6, you can make that plus 6, and that's 14. Then we divide by 2, and we get 7, so y equals 7. Now some of you need to understand what it is you just found, okay? So the original equation said this. You don't need to write this down. You can if you want, okay? So y is 7. So I'm going to replace y on both sides with 7. So 4y, that means 4 times 7 minus 6 equals 2y. 2 times 7 plus 8. So order of operations, okay? Multiplication comes before subtractions. It's please excuse my dear Aunt Sally, okay? So it's 28, and 28 minus 6 is 22. 14 plus 8 is 22. They look equal to me, so 7 has to be the answer, okay? That's exactly what you're finding. Okay, next one, we have 3 times the quantity. 2x plus 1 equals 35. So we have to solve for x. Okay, well, we're applying the distributive property. So 3 times 2x and 3 times positive 1. So that's 6x and positive 3. So plus 3 equals 35. Now, this is pretty well simplified. This is the only variable I have. I just go ahead and solve it, okay? So I have times and plus. So I will subtract 3. 6 times x equals 32. Then I will divide both sides by 6. Okay, 32 divided by 6. If you get some crap like that, you go second PRB, okay? Second PRB equals, and it's 5 1/3. I want exact answers. If they're exact decimals, that's fine, but if there's those that go on forever, no, I don't want those, okay? All right, number 3, 5 times the quantity 3w minus 2, and then when the quantity ends, we have minus 7 equals 23, solving for w. Okay? So I distribute my 5, and that's 15w. If you want to make the 2 plus negative, go for it, okay? 5 times negative 2 is negative 10, so you're going to put minus 10. Then minus 7 equals 23. You don't distribute anything to the 7. Now, this isn't quite in simplest form. I just have one variable term with a times 15, but we can put these two together by adding. You are adding negative 10 and negative 7. Okay, if they're minuses, they're added as negatives. Now, think of a number line, okay? Negative 10, negative 7. Here, I'm going to show you. So I'd start at negative 10, and I'd go 7 to the left, okay? Because you're minus 7 plus negative 7, it means you're going to the left. 1, 2, 3, 4, 5, 6, 7. That's negative 17, okay? So if it's negative 17, we're going to express that as minus 17, and then I go solve. Let's get times and minus, so I add 17. Takes me to 40, so 15 times w equals 40. Then I divide by 15, divide by 15. Again, that's an inexact decimal. You go second PRB, that's 2 2/3. Now I'm going to explain once again what that represents, okay? It's what makes one side equal to the other. So I got 5, quantity 3w minus 2 minus 7 equals 23. So if I think w is 2 2/3, okay, It's going to be 3 times 2 2/3 minus 2 minus 7 equals 23. So this side's equal to 23. We have the value on the right side. Now you do the parentheses first. So you have times and minus. Times always comes before minus. So I take 3 times 2 2/3, 8. 8 minus 2 is 6. Okay? So we have 5 times 6 minus 7. Okay, then what do you do first? What are you supposed to do first? Multiply or subtract? You multiply. Okay? It's please excuse my dear Aunt Sally. So it's 30 minus 7 equals 23. So 23 equals 23. I did it right. I know that that's the answer. And I'm not going to do that for all the problems. You're not going to have time on the test to do it that way. I'm just explaining what it is you found. So we have x minus 2 times the quantity 3 minus 2x equals 2x plus 9. Okay? Okay, we have to get rid of this quantity in parentheses. We are distributing the 2. It is a negative 2 we are distributing. We are distributing the negative 2 to positive 3, and we are distributing the negative 2 to negative 2x. That is a negative 2x. So this side I got 2x plus 9. So negative 2 multiplied by 3 is negative 6. Negative 2 multiplied by negative 2x is positive 4x. Okay. Then there's the matter of this x right here, so I'm just going to add that here. Now, we have 3 different x terms. This would be a 1x. It's a 1x if you don't have it. Now, well, we need to combine the 2 on the same side first. Just add those together. 1 plus 4 is 5. So we have 5x. You can write plus negative 6 or minus 6. It doesn't matter. And then 2x plus 9. Now, don't divide here. You have to get rid of one of your x's by adding or subtracting. In this instance, if I want to get rid of the 2x, I would subtract. You can also get rid of the 5x by subtracting. I usually just get rid of the smaller one. So you have 3x. You can write that as plus negative 6 or minus 6. I don't care. Okay? Okay, so we have to take out the minus or negative 6 by adding 6 to get rid of it. And that's 3 times x equals 15. Then you divide by 3, and x equals 5. Got to concentrate here. Okay, 5 times the quantity x minus 12, n quantity, and then minus 24 equals 3 times the quantity x plus 2. Okay, so obviously you have to apply the distributive property. Okay, equals. So 5 times x, or 1x, it's 5x. 5 times negative 12 is negative 60, so you can write minus 60 or plus negative 60. Now we still have minus 24. And over here, 3 times x is 3x, and 3 times 2 is 6. Now, you have 2 different x variables, okay? First off, before I worry about that, I have these two. These are like terms. They get combined. Okay, see if you can combine anything first. That's a negative 60, and then either think of that as minus 24 or plus negative 24. Okay, it's up to you. It's negative 84. Okay, you can either go like this. The 60 has to be recognized as a negative, and so does a 24. So I add those as negative 84. So negative 84, okay, that would mean minus 84, and then 3x plus 6. Okay, now you have x on opposite sides. So don't divide. You don't divide to carry that step out. You add or subtract. So you subtract 3x, and that's 2x minus 84 equals 6. Now I solve for x by adding the 84 and dividing by 6. Or dividing by 2, excuse me. 2 times x equals 90 divided by 2. And that's 45. Okay. Next problem, number 6. 2x plus 7 minus x equals 3 plus x plus 4. Well, we have a whole crap load of x terms. A 2x, this would be recognized as a 1x, a negative 1x, and this would be recognized as a positive 1x. So we combine the x's on the same side. Okay. 2 and negative 1. Well, think of a number line. You're at 2, and then you can either think of that as minus 1 or plus negative 1. At any rate, you're going 1 to the left. It's 1. Okay, so 1x plus 7. Over here, you got 1x. We can combine the 3 and the 4. Those are like terms, and that's 7. Now, I have x on opposite sides, but they're of equal coefficients, so then those leave the problem. And I have a question, is 7 equal to 7? Yeah, it is. Okay, so all solutions. If it is not true, then it's no solution or undefined solution. Okay, number 7, 5a minus 1 minus 3a equals 2a plus 1. So I got variables all over the place. Okay, well, I combine the two on the same side. You can think of that as 5 minus 3 or 5 plus negative 3. At either rate, the answer is 2. Okay, plus negative and minus pretty much mean the same thing. So 2a, and then you have the minus 1. And over here you got the 2a plus 1. Well, we have that same thing. Now we have variables on opposite sides. Well, I would like to subtract one from the other or add one to the other, but they're of equal coefficients. Okay. Negative 1 equals positive 1. Is that true? No, it's not. That's no solution. Here's something I don't want to see when you get down to a step like that, and I see it all the time. I'll have people mindlessly pick a 2a and subtract it, and then they'll just put that as a. No. Really, 2 minus 2 is 1? Because that's what a means, 1a. 2 minus 2 is 1? It's not. Okay, so don't do it that way. Wipe them out. Okay. All right, now you need to star problem number 8. You'll need to probably study this problem and understand what I'm doing behind it, and I'm going to use the piece of scratch paper to illustrate my point. We have the absolute value of 2 minus 3x equals 4 minus x. I want you to change this problem, please. Okay. I want this expression over here to read negative 2x plus 4. I'm changing the problem. Okay. Now, I see absolute value. That's distance from 0. Distance starts with d. Okay, so d equals negative 2x plus 4. Do I have the d by itself and solve for? Yes, I do. Okay, so, but here's the thing. I don't know if it's equal to a positive or a negative. I'm going to write a bunch of notes here. Positive. Remember, because if d is equal to a negative, it's no solution. If it's equal to a positive, it's I go solve the problem. Okay, we don't know positive or negative. Don't know. Check later. You should be writing this down. Okay. Don't know. Check later. Now, if it had just an 8, I wouldn't have to check. I go 8, negative 8 on this table here. If it was if d was equal like negative 4, I would write no solution, be done. But there's that dang other variable there, and we don't know if it's a positive or negative. So we proceed to solve the problem. Okay. So what we do, we put negative 2x plus 4 on one side, and on the other side we make the 2x positive and switch that to minus 4. Now we bring in the expression 2 minus 3x. You don't switch the 2 minus 3x to opposite. Now you got variables on both sides. Okay, both sides. Don't divide. You pick one to add or subtract. So you got a negative 3 and negative 2. I'll add the 3x. Make sure you're adding it to the x, please, not the 4. So you have 2. That's 1x. Plus 4. If you have a 1x, that's the same as x. Okay. Then all I have to do to operate on both sides is subtract 4. So negative 2 equals x. I will be putting that in later. Okay, now on the other side, we have a negative 2 and a positive, negative 3, a positive 2. I'll add the 3x. You should be getting the x, before you worry about the non-x numbers, you should be simplifying the equation so the x appears one time. Okay, so you have 2, 5x minus 4. Okay. Okay, so you add the 4 to the 2. 6 equals 5 times x, and then you divide both sides by the 5. This is the crap operations you're getting rid of. 6 divided by 5 is 1.2, and that's okay for a decimal because it ends. Now, check later. Okay, you don't know if it's positive or negative, you need to check later. So what you need to do is substitute these answers in for the x right there. So go to your scratch paper and just write negative 2x plus 4, negative 2x plus 4. You can do the same thing where you put a times in parentheses, whatever. Okay, I'm explaining to you what I'm doing. Okay, so I substitute negative 2 for x. Okay. So it's negative 2 times negative 2 plus 4. Well, you times first, okay? You can punch it all into your calculator. I don't care, okay? You can put a negative 2 there, negative 2 times negative 2 plus 4, and then negative 2 times 1.2 plus 4. I'm showing you the steps. So we have 4 plus 4. That's 8. That's positive. That answer is valid, okay? Don't write all solutions on that, okay? Don't do that. Okay, now you put 1.2 in. So we have negative 2 times 1.2 plus 4. Okay, so we multiply. Negative 2 times 1.2 is negative 2.4. So negative 2.4 plus 4 is 1.6. Oh, I got another positive. So both of these are legit answers. These are the two answers to the problem. If I would have got a negative on either one, I would have crossed it out. Okay? If they're both result in a negative output right there, you cross them both out and it's no solution. Don't ever write all solutions on that. These are the two solutions. All solutions means x can be any number, and it can. These are your two. Okay, now we're solving inequalities, graphing the solution. Okay, so solve an inequality like an equation, you just have to worry about the sign possibly switching, and you have to graph your solutions on a number line. Okay. This is a single inequality, so I don't need a table, okay? It's single. So we got 3 times x plus 17. So I have to worry what I'm going to do with the sign. So I'm going to subtract the 17, which never changes the sign. Then I'm going to divide by 3. So since I'm going to be dividing by positive 3, the sign doesn't change there either. Negative 12. Then divide by 3. X, negative 4. Okay, so that needs to be graphed on a number line. Circle, fill it in. That's greater than, it goes this way, and you just label your answer. Okay, number 10, 25 minus 2x is greater than 11. Very similar to this problem, okay? It's a single inequality. So we're solving for the x, getting the x by itself. 25 and 2 is a minus. If you want to make it plus negative 2, go for it. And then the multiplication takes place there. So there's my multiplication. Well, first I have to take out the 25. It's positive 25. Okay. So to take that out, we'll subtract, which will not change the sign. But when I divide, that minus 2 means the 2 is negative. So I'll divide by a negative on this one, which does change the sign. So minus 25. Minus 25. So you have negative 2 times x. 11 minus 25 is negative 14. Now I'm dividing. So x, 7. Okay, so the critical value is 7. Okay, that's a less than sign. It goes this way. So x less than 7. Okay. Next page, this is a compound inequality because there's two of them. And this is a compound inequality because there's two of them. They are both compound inequalities. So to solve compound inequalities as opposed to the single inequalities I just did, okay, you're going to want to make a table. There's no D here though. We're not dealing with absolute value. So I just write them down separately and solve them. Okay. Well, I got times 3. I'll be dividing, but I'll be dividing by a positive 3. I don't care about that number. This is a number we're dividing by, not both sides by. Show your work dividing both sides, you'll see that. So you have x, negative 2. Okay, times 5 greater than, so you divide by 5, so you have x, 20 divided by 5 is 4. Sign doesn't change there either because you're dividing by positive. So the critical values in this compound inequality are negative 2 and 4. Neither one of them are circled because they're not equal to. Okay, so we're less than negative 2. That less ends this way. We're greater than 4. That's this way. So they're going apart. That's an or, and you just label them. X is less than negative 2 or x is greater than 4. Okay, number 12. 2 is less than 4d plus 10, less than 6. Okay, you're not dealing with absolute value though. The d is just a regular variable that you need to solve for. Okay, so that's a compound. I see 2 inequality symbols. I know that's a compound inequality. Okay, so, well, I have this inequality here, and I have this one here. This one here, I have a 2 on this side, then the other side is the expression 4d plus 10. Over here, we have a 6, and then I repeat 4d plus 10. It's got to be lined up correctly too. Okay, so I'm solving for the d variable. I need to subtract 10, which doesn't change the sign, and then I need to divide by 4. That doesn't change the sign. So I subtract 10 from 2, and that's negative 8, and then 4 times d. Now when I divide, I'm dividing by 4, and we have d, negative 2. I'm not a fan of having the number before the variable. Okay, I mean, you can keep it that way if you really so desire, but usually I like the variable in an inequality before the value I found, but then that would switch the sign. Okay, so then when I go to graph, I'm not all screwed up. So minus 10, minus 10, and the sign isn't switching when I subtract, nor is it going to switch when we divide. So 4d, 6 minus 10 is negative 4. You divide by 4 on both sides, and you have d. Negative 4 divided by 4 is negative 1. Okay, so negative 2 and negative 1, not much of a difference between those two. Circle, don't fill them. Greater than negative 2, well, greater than's this way, and less than negative 1, that's this way. Well, you have now an in-between, so you put your variable. Now look here, you see how it eats between the d and the negative 2, it has to eat d, okay? D and negative 1 has to eat negative 1, okay? Okay, number 13, before we get to the story problems. Story problems aren't too bad on this, okay? Oh, there's that nasty absolute value. 5 times the absolute value at 3w plus 2 minus 3 greater than 7. If you start distributing, you're done. Okay, that's not a quantity parentheses. That is an absolute value, which you should be replacing with d. So you have 5d, okay, minus 3 greater than 7, and I will make the table here for later. So I have to find my d value, okay? So I have times 5 minus, so I need to add 3, which would not change the sign, and when I divide, I'll be dividing by positive 5, which would not change our sign. So I would add 3 to take us to 10, okay? And then I would divide by 5, so I have d2. Now, when you come over here, 2 is your value, 2 and negative 2, but you're greater than 2, but you're less than negative 2, okay? So you bring back 3w plus 2, or whatever's inside there, and then you solve it, okay? So I minus 2, which doesn't change the sign. I divide by 3, which doesn't change the sign. Okay, yeah, there's a 0. I don't care, okay? You keep going. I mean, you still have to divide by 3. So you have w, 0 divided by 3, 0. 0 is on a number line, okay? Now over here, minus 2 won't change the sign, and then this won't change the sign. Guys, you can't make careless math errors here. Negative 2 minus 2, here's a number line. Negative 2 minus 2 is this way. Negative 3, negative 4, okay? It's not 0. Now divide by 3. So negative 4 divided by 3. Yeah, I don't want that. Second PRB equals negative 1 1/3. Okay, graph it and you got it. So 0, okay, 0 is actually a critical number. The negative 1 1/3. Okay, so greater than 0, less than negative 1 1/3. That's an OR, so you label it OR. Right there. Okay. Okay, number 14, story problem. The fare of a taxi is $5 per trip plus 50 cents per mile. The fare for the trip from the airport to the convention center is $11.50. How many miles did the taxi cab drive? Okay, you're finding the miles. So the units in the problem are miles and then the money I pay for the miles. That's the two things I'm keeping track of. Now, X and Y, I'm going to assign an X and Y variable to each one of these. Okay. Now, anytime we're dealing with money, money should be Y, and then miles should be X. And the reason why it's that way, because when I set up my per, the rate of change, it's always Y per X. Well, dollars per mile makes a heck of a lot more sense to me than miles per dollar. Okay, so 50 cents times X, that's your slope, that's your rate of change. Now I like to make a table after that. X, Y, miles is X, dollars is Y, 0, 1, 2, and it goes on. Now this is my y-intercept. The money starts at $5. Okay. Then I start adding 50 cents every time I drive a mile. It'd be $5.50. Be 6. Okay. And of course that keeps going. But now I'm going to sketch a graph of the function here, or the equation. It's not a function. Well, it is a function, but equals y. So the y-intercept's 5, and then we begin to add 0.50 every time there's a new mile. Every time there's a new mile, so times x. So now I have my equation I used to solve the problem. 5 plus 0.50 times x equals y. Okay. Now put your $11.50 in the money column. And we are to find out how many miles we have. So y equals $11.50. So you substitute that in place of your y variable. Okay. Plus and times. Okay. So those are your operations. You have to solve for the x. So there's my times. I have to take out the 5. Okay, the 5 is being added. It's positive 5, so you take it out by subtracting it. So that's 6.50. 6.5.50. Now you divide both sides by 0.50, not 50, and that's 13. Okay, so put that on the table, and then that's also the answer we're looking for. Okay, Tracy is looking at 2 travel agencies to plan her vacation. ABC Travel offers a plane ticket for $295 and a rental car for $39 per day. M&N Travel offers a plane ticket for $350 and a rental car for $33 per day. Approximate how many days it will take before M&N Travel is actually the better deal. Okay, so I'm finding days I'm keeping track of, and then of course dollars are as a function of the days. So you got days and dollars. X is days because that's your time unit. Y is dollars. I mean, when I go per, dollars per day makes a lot more sense than days per dollar. Okay, so dollars per day, I have a couple of them. I have 39 that I'm keeping track of. $39 per day and $33 per day. So we're going to have 39 times X and 33 times X. So I'm going to make 2 tables because I'm dealing with essentially 2 equations here that I'm going to combine into one. So days, dollars, days, dollars. Okay. Okay, so $295 is your amount, okay? And you start adding 39, okay? So 295 plus 39, 334 plus 39 more, 373, and of course that can just keep going on, okay? Over here, the $33 per day, they had 350 plus 33, that's 383 plus 33. It's 416, but I'm just showing you what I'm doing rather than, and that goes on. Okay, now there's no end to this. What I want to do is find where the cost here, after how many days, the cost here becomes actually more expensive than the cost here. It's going to, okay? Because he start at 295, he started at 350, but he's going up by 39, he's going up by 33. Eventually he overtakes him as far as being expensive. Okay, so equals y equals y. So we start at 295 and we're adding $39 every day. Okay, he starts at 350 and we're adding $33 every day. Okay. Now I want to find out when these are equal, okay? Now I know we want to find out when one overtakes the other, okay? But I'd have to find that equal point too, and then any point after that, okay? Any number of days after that is when the one that started at the lower cost becomes more expensive than the other. So 295 plus 39 times x. But instead of equaling y, I don't want to know when it equals y. I want to know when it equals 350 plus 33x. Okay, guys, stop. Again, I'm going to repeat that for the fourth time in this video. When you have x's on opposite sides, you should not be dividing. You should be subtracting one of the x terms out of the equation, which would make sense to have it be the 33. Okay, so 6x. You can write 295 plus 6x and then 350. Okay, so you subtract 295, and that's 55. Then you're going to divide by 6, and you will get a weird decimal, but I don't want the fraction here. You just need to round to an integer. Well, you're going to round up because it wants the better deal means, well, 9, it's still not the better deal. 10, then it becomes the better deal. So I'm going to put 10. It would take 10 days, 10 full days for it to become the better deal. Okay, last problem. This one's a quick one if you know how to set it up. There's only one freshman in the cast of a high school musical. There are 6 sophomores and 11 juniors. 1/3 of the cast are seniors. How many seniors are in the musical? So any complex fraction problem, okay, you want this box, fraction, actual. Now when they talk about the 1/3, they're talking seniors. Now I don't give a crap about the rest of it. All I care about this column is that they're not seniors. And then total, okay. Now guys, a fraction's the part over the total, okay. 1 seniors, 3 total. Now you're like, how do I come up with this number here? Well, 1 plus what is 3? Think about it. It's 2. Okay. I'm not trying to be a smart aleck there. I'm just people weren't understanding how to get that. Okay. 1 in this number have to make 3. If there's a 2 and a 7, we'd have to put a 5 in. Okay, now 1 freshman, that's your actual number, but that's not a senior, so I put that there. 6 sophomores, not a senior. I'll add that. 11 juniors, not a senior. Okay, so 1 plus 6 is, wait a second, did I do this right? Yeah, it's going to be 18, okay? So just put 18. Now, you got to find out what you're multiplying by to get from the fraction to the actual. 2 times what's 9? 2 times what number is 18? Okay? I mean, some of you know it, but if you don't, I guess you divide 18 by 2. That'd be 9. So 1 times 9, 3 times 9. So 1 times 9 is 9, 3 times 9 is 27. The question asks us for how many seniors there were, and there would be 9.